polynomial equations by factoring. Write an equation in standard form. That's ax squared plus bx plus c. I'm not worried about that, okay? Just, we want the equation to equal 0. If you find that you have like 3x squared equals 5x plus 2, you got to make one of the sides equal 0. Doesn't matter which side, just one of them, okay? Once you get it equal to 0, then you're going to factor the polynomial completely. That includes greatest common factors and also factoring by grouping, or one of the other strategies, the difference of squares, that kind of stuff. Okay. Set each of those factors equal to 0, which is kind of what we just did on that last problem. Solve the resulting equations, and then just make sure you check in the original equation. And then on that last slide, I actually wrote down what I was checking. In the future, I'm just going to use this because it's convenient. So, the calculator. Let's see what an example looks like. Like I said on that last one, we would have had to do some factoring, right? Equals 0. That's a problem. We're gonna force it to, though, right? So I'm going to go into this, and let's force it to equal 0. So for me, I'm going to make it equal to 0 on the right side, right here, okay? So that means the 24x, I need to force it to become a 0. Now, since I'm going to force it to become a 0, this goes back to principles of equality. If you're going to make zeros, that means you're going to either use addition or subtraction principles of equality. Multiplication and division principles of equality are for making ones. This is a 0. So how do you make a 24x a 0? Just subtract 24x. Okay, now on the left side, I'm going to actually put it in the middle, minus 24x. That means I'm not going to combine it with 16x squared because it's not a like term with 16x squared. It's not a like term with the 9 because that's just a constant. So what I now have on the left side is 16x squared minus 24x and then plus 9. And why did I put the negative 24x in the middle? Because it goes back to that format that we've been seeing when we factor trinomials like this. Okay. Now, this one's actually going to give us kind of a break because I look at 16 and I look at 9, right? I look at the two ends right here. Both those are perfect squares, which means that right here, I could just make that 16x squared a 4x to the power of 2. And then the 9, I'm going to make that a 3 to the power of 2. Now, we still need to check, right? We still need to check. So the 24x, is that 2 times a, which is 4x, times the b, 3? It is. 2 times 4 is 8, times 3 is 24. I don't really care about the minus sign right here because that just tells me what sign is going to go in between the two values in my binomial, right? But my two values are 4x and 3. Now, if you factor this by grouping because you didn't notice that it was a perfect square trinomial, don't worry about it. You should get the same exact binomial to the power of 2 right there. Well, in the past, we were able to finish and then feel good about what we just did. But now we get more work to do because it's so fun. So we're going to take that. By the way, I don't have to do this twice because you're going to get the same answer, right? It's just squared. I mean, you're welcome to do it twice, but you'll see you get the same answer. So I'm going to take that 4x minus 3, right? And I'm going to make it, this is the inside of that parentheses. If I could make it equal to 0, I'll get a true statement from my original equation, which is what I want. I probably need more space, though. So right here, let's figure this one out. Oh, what the heck? So plus 3 on both sides. I'm skipping some explanation. Hopefully that's okay. But my 4x I can drop, which now equals 3. And then last of all, I'll divide both sides by 4. And so it looks like x in this case would equal 3/4. Now, again, if you separated this into two separate binomials, you'd be solving the same equation twice, which I don't want to do. So I'm not. But I will check. Okay, so I say, I'm going to go back to the top here, and I'm going to replace the x. See if it'll let me do it. The x I'm going to replace with 3/4. But there's two x's, right? So 3/4. And I'm going to put a question mark over the equal sign to see what I get. Okay, so in my calculator, I got 16 times 3/4 to the power of 2 plus 9er equals, and I get 18 on the left. And then 24 times 3/4 is also 18. That's a true statement. Yeah, it was the x was the 3/4 was squared, but this is true. So I found that by replacing the x with 3/4, I did get a true statement, which makes this my solution. Again, there is technically a second solution right here, but it's the other 3/4. There's a reason for this. It's graphically, but we don't want to get into the graphs yet. You know what? I'll demonstrate this because the technology is going to make it easy. But I can do this twice because, boom, there it is. I did it twice. But I got the same answer twice, you know what I'm saying? So it does have two answers, just the same answer twice. I just don't want to list it twice. Like if you put 3/4 in the assignment, then 3/4, it'll be like, what the crap? And then you'd get marked points, which we don't want.